Alright, before we jump straight into balancing chemical equations, there's some things you need to do beforehand, and some things you need to understand. Alright, so first, what you should do first is identify the reactants on the left-hand side of the equation. I'll represent this with an R, reactants, and on the right-hand side, this is essentially what you're producing, so this is called the product. Product, I'll represent that with a P. And the second thing you should know is you should understand which elements you have at hand. So on the left hand side we have a hydrogen and we have chlorine, and on the right hand side we have hydrogen and we have chlorine. Alright, and then now you should see how much of each element you have. So we have 2 of each on the left hand side and we have 1 of each on the right hand side. Alright, before jumping into changing numbers and changing how much of which element you have, you should remember that you can never change a subscript. Alright, what does this mean? So say you have a hydrogen with a subscript of 2, and you wanted to make it 3 hydrogens instead of 2. You needed 3 hydrogens to finally complete balancing these chemical equations that you've been doing for so long. So what you could do is, for having it for 3, you could balance it in order for both sides to equal to 6, but you can never balance it just by changing what's here, changing the subscript, and just making it a 3. This is completely incorrect because it's no longer hydrogen gas. Think about it. A hydrogen gas atom is when two hydrogen atoms bond together. This is a diatomic molecule, so it is when 2 hydrogen gas molecules bond together. But when it is a H to the subscript of 3, it's just not working because it is no longer hydrogen gas. So you cannot change the compound or element that you're working with. But what you can do is let me erase this. So you have hydrogen, you need 2 hydrogens, you could put a coefficient because now you're saying you have 2 of the same molecule. So you can have 2 hydrogens, you could have 2 hydrogen gas molecules, but you could never have 2 hydrogen gas molecules that are bonding 3 times. It's just changing the law that you're working with. Alright, so now let me clear up some space. Alright, so oops, I deleted this by accident. So we have 1 of each on the right hand side. We have 1 of each. So what we can do is we could put a 2 in front of hydrochloric acid right here. We could put a 2. So now this changes both hydrogen and chlorine. Since it is a coefficient, it applies to both elements. So now we have 2 hydrogen, we have 2 chlorine. And now you see on the left hand side we have 2, we have 2, and we have 2, and we have 2. So now that all the numbers are the same on the left hand side and on the right hand side, the reactants equal the products. Now you know that the balanced chemical equation is true. Alright, that was a fairly simple chemical equation to balance. Now I'm going to move on to something a little more difficult. Alright, with this chemical equation, we are dealing with three elements. We have on the left hand side and both on the right hand side, we're dealing with aluminum, which is a metal, chlorine, and hydrogen. Aluminum, chlorine, and hydrogen. So when you go through the process of balancing chemical equations, something you should know is it is always easier to balance the metals first, then proceed with the non-metals, and the last things you want to balance is hydrogen, oxygen, and carbon. You would balance carbon, hydrogen, then oxygen in that order, but you can also balance it however you like as long as it works your way. But I suggest definitely balancing the metals first, as it is the hardest to balance. Alright, so on the left hand side we have 1 of each. We have 1 aluminum, 1 chlorine, and 1 hydrogen. And on the right hand side we have 1 aluminum, 3 chlorine, and 2 hydrogens. Alright, so the aluminums, which is the metals, is already balanced, so we could check this off. Actually, not 100% sure yet. It could change anyway, so let's just keep it like this. Aluminum 1, and chlorine, we need to triple up on chlorine on this side, on the left hand side. So what we could do is put a 3 right here. Now we have 3 chlorine, and we have 3 hydrogens. Alright, so now the aluminums are balanced, the chlorines are balanced. Now all we have left is the hydrogens. So we have 3 and 2. We cannot balance 2, 3, and we cannot balance 2. We have to find the lowest common multiple, which is 6. So we have to have hydrogen multiplied by 3 here. This makes this a 6. And we have to have hydrogen multiplied by 3 here. So we have to get rid of the 3, and we have to have it as a 6. We have to have it as a 6. So now we put a 6 here. So now hydrogen is balanced, aluminum is balanced. We could get a check there, check there, check there, check there. But oops, wait a minute. When we change the hydrogen, we also change the chlorine. So now chlorine is a 6. So what do we have to do on this side? We have to put a 2 here. We have to put a 2 here. So now chlorine is a 6. But then aluminum is now a 2. Aluminum is now a 2. So we could get rid of this check mark sign. Get rid of this check mark sign, and now we know that aluminum is a 2. Alright, so now we're very close to, now we're very close to balancing these chemical equations. All we have to do is put a 2 in front of aluminum here to balance this. So now we have a 2 here for aluminum, 2 here for aluminum, 6, 6, 6, 6. Everything is good. So now the chemical equation is now balanced. Alright, let's move on to the last and final example. Alright, with this chemical equation, as you can see, it is a decomposition reaction, which is breaking down of chemical equation. So on the left hand side we have a potassium, we have chlorine, and we have oxygen. And on the right hand side we have the same elements, potassium, chlorine, and oxygen. Alright, so on the left hand side we have 1, and we have 3. And on the right hand side we have one potassium for KClO4 and 1 for KCl, so we have 2 together. We have 2 chlorines, and we have 4 oxygens. So let's start off with balancing the potassium first, as it is the metal. So we have to double up on potassium. So in order to do that, we have to put a 2 in front of potassium here. So that makes potassium 2, but also changes everything else. So now we have 2 chlorine, and now we have 6. We have 6 oxygen. So now what we could do is we look at oxygen, we look at the oxygen on the other side. Everything is balanced. Potassium and chlorine is balanced, but oxygen is not. 6 and 4, what we have to go up to is, I believe, 12, right? Yeah, 12. So we would have to triple up on this. So we have to put a 3 here. This makes oxygen a 12. 3 times 4 will give you 12. And this makes chlorine a 3. This makes potassium a 3 plus 4, so that makes it 4. Alright, so now we have to change everything on the left hand side once again. So now we have to go here, and we realize, oh, we have to get rid of the 2 as it is no longer valid. We have to get rid of the 2. Let me make the eraser a little smaller. We have to get rid of the 2. And we realize, okay, in order to get to 12, we have to put a 3 times 4. We have to put a 4 here. So now, oxygen is 4 times 3 is 12. And we have 4 potassium. And we have 4 chlorine. So now, this isn't. This is 3. Yeah, sorry, this is 4 because I didn't realize. We have 3 right here. And then we have another one right here. So there's 4. Alright, so now we see that we have 4 potassium, 4 chlorine, 4 chlorine. We have 12 oxygen, 12 oxygen. So the chemical equation is now balanced. Alright, a little recap about what we just went through is, when balancing chemical equations, say you have CH4, and you wanted to change the amount of, actually let me separate this a little more. So you have CH4 like this. It's a little separate, but it will have to do. So say you have CH4 right here, and you wanted more carbon, and you thought putting a number in front of here changes the hydrogen. So why do that? Why would I do that if I could just put a number here? You see, now this is incorrect. This is a big no, big no, big no. The reason for this is because now it is no longer CH4. CH4 is methane. When you change it to C2H4, it is no longer methane. This is no longer methane. Methane is only CH4. So the ratio of carbons and hydrogens have to be the same in order for it to maintain as methane. And when balancing chemical equations, the process you would have to go through is 1. Identifying the reactants and the products, 2. Identifying what elements and compounds you have at hand, 3. Seeing how much of each element you have, and 4. Changing the coefficients on each compound or element to satisfy the balancing chemical equation and to make the equation more balanced. Alright, thank you for watching, and I hope I helped.